Hey guys, it's N54 Garage and welcome back to part 4 of the built motor series. In the previous parts, as we've seen, we refreshed the cylinder head. We also converted the 9mm studs to the 11mm studs, and we also epoxy closed the deck. In this video, I will be assembling the rotating assembly. We will be installing the crank with new main bearings. We'll also be gapping the rings, installing the rods and pistons, and new rod bearings as well. I did end up going with Manley rods and pistons. My last built motor, I did use the same rods, but I went with JE pistons. These pistons are 84mm. The reason why I decided to go with 84mm instead of overboring to 84.5 is when I had the machine shop check over my cylinder walls, and they told me that it was okay to use a standard size piston. So I ended up choosing the Manley standard size piston, which is 84mm. And it also is a standard compression ratio, which is 10:1. I didn't want to go low compression as I did want to run less boost, but still make the same amount of power as running high boost, but with a lower compression motor. My last built motor was lower compression, which is 9:5:1. That motor did great. I had no problems with it. It also did have a standard size piston as well. Obviously, before I install any type of parts in the motor, I do measure my clearances. So my main concern would be the piston to cylinder wall clearance. So Manley does suggest that for BMW motors, a coated skirt piston, it calls for 0.0035. As you can see, we're just a little bit over 3 thou, so about 3.5 to 4. So piston to wall clearance, we are in spec according to Manley sheet. This tool is also set accurately of the size of the piston, and we zeroed it out to this, and we checked it in the bore. Or just a little bit smaller, 4 thou, so between 4 to 3.5 thou, so we are good to go. This piston is a 2618 alloy, so which means that it does have a little bit higher expansion rate. So as the motor heats up and gets to operating temp, the piston will actually expand and get a little bit bigger. But the thing is, with this alloy, it's actually very strong, it's less brittle, and it also absorbs combustion a lot better. So if you were to use a 4032 alloy piston, that material has less expansion and it is a little bit more brittle. And I also heard that this alloy is on a cheaper side, so most of your Chinese pistons will be this alloy. Most forged pistons are 2618 alloy, so just something to consider. I am also using a standard size Manley rod. For the crank is in excellent condition. It is an 8-bolt, but like I said, I will be running an aftermarket flywheel. The only thing I'm going to do is lightly polish the journals because, I mean, this crank has been sitting for a little bit and I can just see dirt piling up on it. As for weighing the pistons and balancing, unfortunately, I'm not going to be balancing because, I mean, it is over my budget and this is a DIY build. I had no issues not balancing my other built motor. That motor runs fine, but I am going to weigh each rod and piston. I already weighed all my rods. This one is the heaviest, so what I'm going to do, just don't take my word for it, I'm basically also going to weigh the pistons, pair the lightest piston with the heaviest rods, and then go from there, just to sort of balance everything out. I'm not really going to grind material off just to get everything the same weight. I'm not a high-end engine builder. I don't have 30-40 plus years of experience. I'm just a guy who builds cars in his own garage. So if this fails, you guys can go and bash me in the comments, but this is how I'm going to do it. I also already went ahead and I did my measurements with the piston rings. So the standard bore in inches is 3.307. I also measured the OEM ring. So these are the OEM rings in the bore. So the top ring is 0.011, bottom ring is 0.024. A lot of people say that this is a pretty tight clearance for high boost, which is why a lot of people crack their pistons, their ringlets and whatnot. Then I also went ahead and measured the top and bottom ring for the Manley pistons, and we get a 0.011 for the top and a 0.021 for the bottoms. For the oil rings, we won't be touching those because they already are in spec, so those would just be dropped in. But we will be sizing and grinding the top and bottom ring. I'm just gonna go off of what Manley says. So we are gonna do high boost, most likely past 30 pounds. What they recommend is, so you would multiply your bore size, 3.307 times 0.008, and we get 0.026. So that's what they want us to gap our top ring. As for the bottom ring, we'll do the same thing. So bore times 0.008, and we also get 0.26. So theoretically, this is what I would gap my rings to and what I think is best for me. So remember, this is what I think is best for me. You guys do what you want. The 30+ year engine experience builders, you can comment all you want, but this is what I'm gonna do. If it works, it works. If it doesn't, it doesn't. For most of the engine's life, it's probably not gonna be over 30 PSI. It's probably just gonna be daily at around like 28, 30. So for me, this is what I'm gonna gap my rings to. So my top ring, I'm gonna do 0.024, and my bottom ring, I'm gonna do 0.026. You also have to keep in mind, as the engine breaks in, that ring gap will get slightly larger. So it won't be perfectly 0.024. It will get a little bit bigger as the engine breaks in. As I feel like if you have the top ring slightly smaller and the bottom ring slightly bigger, you will prevent, as people say, I guess they call it flutter, and it won't have exhaust gases trapped between the rings. So I think this is a pretty good ratio. I went ahead and laid out all my piston rings from cylinder 1 to cylinder 6. So the way I'm gonna do this is I'm gonna take my top ring. On the ring, there's writing that says 3.307, which is the bore, the standard bore size. That means that this is the top side of the ring. So we put the ring in. I'm gonna use an OEM piston that I cleaned up to push it in. I only need to push the piston ring in about 1 inch into the cylinder. You want to make sure that the piston is pretty much nice and straight all the way around. Just for a quick reference, we are going to take the feeler gauge, and we're going to take the 0.011 measurement, and we're going to put it into the ring gap. It slides in there pretty nice, and you can feel the piston ring grab the feeler gauge a little bit, which means that we are right at 0.11. That is the standard ring gap, and now we need to open it up to 0.024. I am going to be using this simple grinding tool. I mean, you can get this tool off eBay, Amazon, anywhere. It's very cheap. You grab your piston ring. You want to make sure, I mean, whatever end you're grinding, you want to make sure that it's nice and straight and squared with the grinding wheel. Now you turn it to the direction where the grinding wheel is grinding downward. You want to go slow with it and apply a little bit of pressure to the piston ring. Now after you're done probably about a few turns, maybe like 5, 6, you want to go back and you want to check to make sure how wide we open it up. After you grinded it a few times, you do want to take a fine file or very fine sandpaper and just kind of knock down the edge that you grinded. They will be sharp and they can scratch the cylinder walls. We are just at 0.024. Once the feeler gauge is kind of tight in there and it starts to grab the piston ring, that means you're done. We are done with one cylinder. Now we do the rest. After we finish doing the top ones, we do the bottom ring to 0.026. All right, so that's the last ring. This is the second compression ring that we did gap to 0.06. So we are basically all done. Now it's time to install the crank. Before I install the crank, I am going to install the oil squirters. I'm not going to torque them down just yet because I want to keep them loose, because once I install the rods and pistons, I want to make sure as the rotating assembly turns that the rods and pistons do not interfere with the oil squirters. I would just put them in a relatively close position as OEM, just so you have kind of a set point. After we're done that, I am going to be installing king bearings. So this is just a standard size. So I'm going to install the bearings separately on the block and on the bed plate. So you can't really mess this up. The bearings with the grooves go on the block, and then the smooth bearings without this middle groove go on the bed plate. Because this notch right here won't line up on the bed plate, it'll only line up on the block. I am just lightly wiping them. I'm not putting a lot of pressure because from factory there tends to be some dust on them or some lint. I'm gonna go ahead and lube only the bearings on the block. I'm using this stuff right here to lube up the bearings. Now I'm gonna set the crank in, but I'm not gonna turn it because I do want the top side of the journals dry because we are gonna check for clearance. We're just gonna be using standard plastic gauge. It's probably not the most accurate, but will give us a relative idea of what our bearing clearances are. So I'm just gonna cut a small little strip and put it on each main journal. So we got plastic gauge on every single main journal. Now all we do is we throw on the bed plate, the old bed plate bolts, and we torque them down to spec. So 20 Newton meters and then 70 degrees.
I'm not really confused. Now like I go by Snapchat memories and it shows me the video.
20 Newton meters. Now we do 70 degrees. Now we remove the bed plate and we check our clearances. For our main bearing clearance, we need to be between 0.02 and 0.046. So on the plastic gauge, it might be kind of hard to see, but this big green box, we can be just a tiny bit bigger than this green box because this green box is 0.025, but we also can exceed this smaller green box. So it needs to be somewhere between there. So this might be a little hard to see, but I went on the bed plate side because it is a little bit easier to see than on the crank. We are just at 0.25, and some of these are just a slight hair bigger than our 0.25, which is actually a very good clearance for our 0.02. So we are in very good spec. Just be very careful while removing this. Take a rag and spray a little bit of oil on it, which it does help remove it a little bit easier. Try not to push hard because you don't want to take the coating off the bearing. Now you guys could spin the crank just a little bit, make sure nothing's binding. What I'm going to use to seal the bed plate to the block, I'm just going to use this stuff right here. This is just a Permatex, just regular RTV. I used it on my last 2 built motors. I even used it on other motors and other small rebuilds, and I never had any problems with leaks. I'm just going to do a nice bead right along this groove, a nice fat one right along here, just so it seals this area. They also did discontinue the OEM sealant that they used for this bed plate. So now there's some other stuff that they tell you to use, but I'm just going to use this. Now we put the bed plate on. Now we take new bed plate bolts. Make sure you guys oil them up. (20 Newton meters). (70 degrees). So now we can go ahead and tighten all these small aluminum bolts all the way around the bed plate. So these ones are 15 Newton meters and 90 degrees, and these 4 outside ones are 10 Newton meters and 90 degrees. Bed plate is on. Remember guys, new aluminum bolts and new bed plate bolts. That's very important because they are torque to yield. So now let's give the crank a spin. Look at my pinky. Nice and smooth, look at that. So now it's time to put the rods and pistons in. Before we start throwing in the pistons and rods, you guys do really want to clean your cylinder walls. Take a lint-free rag, put some oil on it, and try to really deep clean the cylinder walls. Use a few rags if you have to, just to get them nice and clean and free of dirt. I have my rods and pistons laid out from cylinder 1 to cylinder 6. My rings are also ready. I kind of tried my best to weigh them and matched heaviest piston to the lightest rod and lightest piston to the heaviest rod. There is an arrow on the piston which tells you that that direction goes to the front of the motor. Another way to tell is by the valve cutouts. The exhaust cutouts are a lot smaller than the intake side, so you know that this side goes to the intake and this side goes to the exhaust. As for the rods, I'm gonna have mainly facing to the front of the engine. Also, before you guys install these, you guys do really want to clean them. The first thing I'm gonna do, I'm gonna install one wrist pin clip on either side of the piston, doesn't matter which side. They are pretty tricky to install. I'm just gonna use a flathead screwdriver. Try to be careful with it. You don't want to scratch your piston or dent it. For installing the wrist pins, I'm going to use Lucas assembly loop. You grab your piston and you slide it in on the opposite side that we installed the clip. Make sure you guys watch that arrow and you watch the lettering. So I'm going to install it like this, nice and slow. Also, don't forget to loop this up. So once you push it all the way through, it's going to push against the clip. So now we install the clip on the opposite side. That's one done, 5 left to go. We're all done assembling the rods, the pistons. So now it's time to install the piston rings. Make sure all the rings are clean because there could be some dirt on them from the factory. So I'm going to first install the oil ring, the small oil scrapers. Then we take our bottom compression ring. It says up, so that means that we face the ring up this way. Same goes for this ring. The numbers mean up. I am also going to oil all the rings before I install them. Make sure you guys oil the rings and the cylinder walls with whatever braking oil you guys are going to be using. I'm going to be using this stuff right here. Now we install the rings to the rest of the pistons. I am going to be using standard size king bearings, and I also am going to be checking for clearances. Try to be very careful with them because they do have a coating on them. Make sure you guys really clean these ends. One thing to note, so you guys don't get confused, orientation this is. So there's numbering right here and right there. That means those numbers should be in the exact same spot. For now, I'm just going to lube up the piston side of the bearings because we are going to check for clearances, and I do not want assembly lube on those just yet. But before we install the piston, I am going to set my rings accordingly. This is the correct way to set your rings. You set the top compression ring right here, bottom compression ring here, the bottom oil ring here, and the top oil ring here. And then the oil expander, which is that wavy ring, will pretty much go anywhere between these two lines. So this is the correct way to do it according to Manly. Make sure you guys oil up the rings. I'm going to be using this tool right here. It's not the best. I recommend to use a fixed piston tool, not one of these. These are actually pretty bad, but I can make it work. So we place the plastic gauge, then we make sure you install the rod cap the correct way. Like I said, no lubrication. Add a little bit of oil. I will be torquing the rod bolts to 65 foot-pounds. This is the spec that Manly recommends. So the number that we need to be between is 0.025 and 0.07. So anywhere between these two numbers is in spec. So we are just at 0.38, maybe a little bit bigger than 0.38, but we are between 0.038 and 0.051. So we are in spec. Now I repeat the process for the rest of the rods just to make sure that we are in spec. All the rods are torqued down. I checked all the rods for the clearances and they're all perfect, and they're all torqued down to 65 foot-pounds. Now the only thing we need to do is torque down our oil squirters. So basically you move them so they clear the pistons and the rods and they're not in the way, and then you torque them down to 12 Newton meters. We are all finished. The rotational assembly is together. Everything spins nice and smooth without binding. I hope you guys enjoyed part 4 of the Built Motor series. In the next video, we will be installing the cylinder head, torquing the head studs, and I'll also be showing you guys how to time the motor correctly. As always, guys, thanks for watching and stay tuned for more videos.